Good morning, everyone. In today's session, we will be looking into the various aspects of test and we will be looking into what you mean by type 1 and type 2 errors. In the last module, we had covered what is hypothesis, what are the steps involved in hypothesis, importance of hypothesis testing. These were the things which we dealt with. So, in hypothesis testing, there are possibility of two errors which can happen. One is called type 1 error, and the other one is called type 2 error. So, in the different types of hypothesis which we looked upon on the previous modules, we came across what you mean by null hypothesis and what is the H1 hypothesis, H0 which is null hypothesis and the H1 which is alternative hypothesis. Type 1 and type 2 errors. If we are accepting an hypothesis, when the hypothesis is true, it is a good conclusion. And if we are rejecting an hypothesis, when the hypothesis is false, again it is a good conclusion. So when you reject a hypothesis when it is false and accept a hypothesis when it is true, it is good conclusions. See this and this part. Now, even though the hypothesis is true, if you're rejecting the hypothesis, it is called type 1 error. And when you are accepting a hypothesis, when the hypothesis is false, is called type 2 error. So, rejecting when the hypothesis is true is type 1. Accepting when the hypothesis is false is called type 2. So, put it in words. Type 1 error is something where when the null hypothesis is true and we are rejecting the hypothesis, and the other one is when we are accepting the null hypothesis when it is wrong. So these are type 1 and type 2. So false positive is type 1 and false negative is type 2. So to make you understand in much simpler thing, look it into this picture. In the first picture, if you are saying doctor is telling a man that he is pregnant, that means it is a false positive. That is type 1 error. In the second one, you are telling a pregnant lady that you are not pregnant. It is a false negative. That is called type 2 error. So these are the two errors. When you are rejecting an hypothesis when it is true, it is type 1 error. When you are accepting a false hypothesis, it is called type 2 error. Hope you will remember this one. A false negative is type 2 and a false positive is a type 1 error. So this is about type 1 and type 2 errors. When you are accepting a hypothesis when it is false is called type 2 errors, and rejecting a hypothesis when it is true is called as type 1 error. So now moving forward, if you have seen in the first slide, we have told about what you mean by parametric and non-parametric test. So let's see what you mean by parametric and non-parametric. Parametric tests are those that make assumptions about the parameters of the population distribution from which the sample is drawn. Usually, parametric tests can be done only if the data is normally distributed. That means it is a bell-shaped curve where we have both sides symmetrical. And non-parametric tests are performed for those where the distribution is free. We are not able to form a proper like we are not able to trace it as a normal distribution, or we can't predict which distribution it is. That place we will be using non-parametric. So in parametric itself, we will be looking into parametric tests. There are four types of tests, like a t-test, Z-test, ANOVA test, then chi-square test, and all those things we are using parametric method. That means we are assuming that it is a normally distributed one. So let's see the different types of tests in the coming thing. So the first test which we will be doing is Z-test. Okay, a Z-test is a statistical test for which the distribution of the test statistic under the null hypothesis can be approximated by a normal distribution. That means it is a normal distribution. That means the mean, median and mode will be in a central location. And this Z-test is used when the sample size is less than when sample size is more than 30. Z-test is used when sample size is more than 30 and when the population standard deviation is known. The population, how the standard deviation is, if it is known and if it is normally distributed and if the sample size is more than 30, we will be using Z-test for your hypothesis. So there are three things. First one, the standard deviation of the population should be known. Second thing, it should be normally distributed. Third one, the sample size should be more than 30. So here basically it is used to determine when two population means are different, when the variances are known and the sample size is large. Okay, it is a popular test for judging the significance of mean and proportion. It is used for t distribution and binomial or Poisson distribution also when the size of the sample is very large, on the perception that such a distribution tend to approximate normal distribution as the sample size becomes larger. And usually it is done to know about the testing the hypothesis about the differences between two means. Okay, so Z-test, let me again tell, there are 3 points. Normal distribution, the standard deviation of the population should be known and the sample size should be more than 30. So these cases we will be using Z-test. So for your knowledge, we should just know in this stage what is Z-test. So I hope it is known. It is a parametric test because we know the distribution pattern. Second one, the sample size should be greater than 30. The standard deviation of the population should be known, and the third factor being the data should be normally distributed. So that is about Z test. Now coming to the t test. T test is similar to or almost same as Z test, but here the thing is a t test is performed when population standard deviation sigma is unknown, it is not normally distributed, and the sample size is less than 30. So in t distribution we are considering that the standard deviation of the population is not known, that is unknown. It is normally distributed just like Z test and the size is less than 30. The sample size is less than 30. In these cases we will be using t distribution. In the Z distribution we were comparing the means of two different populations. So in t-test, it is called univariate test. That means only one variable is taken into consideration. It used t-distribution, which is symmetrical bell shaped curve, that is normal distribution curve, and for testing sample mean and proportion. Okay, so we assume that the mean is known, standard deviation is unknown, and the sample size is less than 30. So these are the difference between t-test and z-test. Again, this is a parametric test because the distribution is known and it is based on the normal distribution curve. Yes, so hope it is clear. T-test, the sample size is less than 30. Z-test, the sample size is more than 30. Standard deviation is known in case of Z-test. In T-test, it is unknown. then normal distribution in both the cases. Okay, so that's about t-test. Now next one, chi-square test. A chi-square statistic is a measurement of how expectation compare to results. Okay, here in chi-square, the data used in calculating a chi-square statistic must be random, raw, mutually exclusive, drawn from independent variables, and drawn from large enough samples. The sample size which should be more, and it should be randomly taken, then mutually exclusive. That means if one occurs, the other can't happen. For example, mutually exclusive means tossing the coin. Either you can get head or tail. Okay, so that is mutually. If one is occurring, the other can't happen. So like tossing your dice, in either 1, 2, 3, 4, 5 or 6 can happen, but all together can never happen together, and it is drawn from independent variable. Okay, so that is about the chi-square. The formula of chi-square is, this is how chi-square is written. Chi-square is equal to OI minus EI square by EI. What is O? Is observed values, E is expected value, C is the degree of freedom. Okay, so what are the assumptions of chi-square? Let's see. What are the assumptions of chi-square and what are the applications? Assumptions of chi-square test is, it is a simple random sample which we are using. The sample data is a random sampling. That means the chances of occurrence of anything at any time is equal. Okay, equal probability of getting selected. Sample size should be very large in case of chi-square test. Then expected cell count, adequate expected cell count should be there. Some request 5 or more, and others require 10 or more. So that is another thing. There should be different conditions which we are applying, and independence. The observation are always assumed to be independent of each other. That is mutually exclusive. And applications of chi-square, again it is a parametric test because it follows a normal distribution. Chi-square distribution typically looks like a normal distribution. Either it can have a skewedness. That means either the right hand side can be tapering or the left side can be tapering. Usually it will be the right side which will have a long tail. The test this is used to test the sample difference among various sample proportions as significant, or can they be attributed to chance. It is used to know the independence of two variables in a contingency table. Again, this is just for your information. Like you should, as a BBA student, you should know what are the different tests. So till now we have studied 3 tests. First we studied what is parametric test, what is non-parametric, what are the 3 different parametric tests. One is Z test, T test, and the last one chi-square. So in this module we have covered what is type 1 and type 2 errors. Okay, I think this will explain. When you are rejecting a true hypothesis, it is type 1, and if you are accepting a false that should be rejected, it's called type 2 errors. What do you mean by parametric test? What are the different parametric tests which can be used? Usually non-parametric tests will be used in behavioral science, where the distribution cannot be clearly determined or told. Then there is Z test. When the population sizes, when the sample size is more than 30, you will be using Z test, and when the standard deviation is known. T test, when we don't know the standard deviation of the population, but the sample size is small, less than 30. And chi-square test is again a parametric test where there are certain assumptions which are made, and these are the assumptions. I hope it is clear. So in the next module, we will see the last thing, which is ANOVA. In this, whatever we learned, I hope it was understandable. Thank you very much. If you have any doubts, please feel free to contact. Thank you.